final session of Step to IoT, a webinar series on the Internet of Things organized by IET on campus, University of Peradeniya. In this fifth webinar session, we are going to discuss about the applications of IoT and how it can be used in undergraduate projects. For one last time, let me introduce the guest speakers of this event, Mr. Anuradha Udunuwara and Mr. Rajiv Weragama. Engineer Anuradha Udunuwara is the Senior Enterprise Solutions Architect at Sri Lanka Telecom with more than 17 years of experience in the industry. He graduated from the Faculty of Engineering of University of Peradeniya with a bachelor's degree in Electrical and Electronics Engineering. He is also the world's first MEF Network expert with many other related achievements. Moving on to Engineer Rajiv Weragama, he is a senior engineer at Sri Lanka Telecom with more than 12 years of experience in the industry. He has a bachelor's degree as well as a master's degree in Electrical and Electronics Engineering, and is currently pursuing a PhD on the Internet of Things at the University of Peradeniya. Apart from being engineers at SLT, both of these individuals are trainers, researchers, as well as well-known speakers at Commonwealth Telecommunication organizations. Now, without any more delay, Mr. Weragama and Mr. Udunuwara, the session is over to you.
Thank you, Siri, for your kind introduction. So, can you see my presentation?
Yes, sir.
Okay, so we have come to the end of this webinar series. So today is the fifth and the final day of Step to IoT webinar series conducted with the collaboration of IEEE and IET sections of University of Peradeniya. So in the first 20 to 25 minutes, I think, we will discuss the domain-specific IoT as well as its applications. And thereafter, Engineer Anuradha will discuss the most important thing of this webinar series. That means how we can use the Internet of Things concepts in your future projects as well as the applications. So the Internet of Things, there are so many applications in Internet of Things. So it spans over multiple sectors, but it is not limited to the domains which I have mentioned here. So there are so many applications related to healthcare, homes, energy, agriculture, and cities, as well as transportation. So these are the most prominent domains where the IoT has been used in the modern world. If you look at the healthcare sector, today we see a large number of smart medical devices. So these devices are used for life-saving, and also that is achieved through monitoring certain parameters related to our bodies using the IoT technology. So that can be the virtual glasses or fitness bands to monitor the calorie expenditure and also the heartbeat, or GPS tracking belts. And those are some examples for these devices. I think most of you have already seen these smart wearables like the smart bands in your real life. So they detect and record the patient's heart rate, temperature, the breathing rate, as well as the breathing pattern, and also any sudden movement. And if you move more deep into the healthcare sector, you will see some specific wearable as you now see on the screen. So there are the connected ECG monitors, and also some kind of equipment which can detect any injury caused to a player before that happen. And also there are pain relief wearables as well. So just think of a scenario where uh, you have some kind of a wearable on your body, which is connected to the internet, and it measures the data related to your heart rate, the breathing pattern, and any other sudden movements on real time. And through the internet, this device can send all this data to your family doctor. So let's say you get a sudden heart attack. So what will happen? So the device is capable of sending all this data to your doctor. So before your family members take you to the nearest hospital, using the location-based services and other edge analytics, the nearby hospital crew knows that there is a patient who got a sudden heart attack, and there is a higher probability that he or she will be taken to their hospital. So they can get ready before you arrive there. So what happened today is that the hospital staff is totally unaware of the situation until the uh, family members or your friends take you to the hospital. So when they get ready, that will take some time. So that small bit of delay can cause a death as well. So if the medical staff can get ready to face the situation, so that will help to save so many lives. Another use of the integration of IoT technology is that nowadays they are using these devices in hospital beds as well. And that makes the hospital beds kind of a smart bed that is equipped with special sensors to observe the vital signs, blood pressure, and also it has oximeters. And there are so many things which can be measured when you are lying on that bed. And we have some sort of smart garments as well, like the smart shirts and smart socks. So these are equipped with the number of sensors which measure heart rate and also the heart rate variability, breathing rate and breathing volume. These are capable of controlling the breathing, and also they can prevent respiratory problems like hyperventilation. And these garments uh, measure the activity matrices, including the steps, intensity levels, distance you walk, and the amount of calories you burn, and also the pace you walk. And these smart socks are designed for the runners who want to track how far and fast they run, as well as how well they run. Currently, over a billion of people, including children, and in fact, about 15% of the world's population are estimated to be living with some sort of disability. So the lack of support services can make these handicapped people overly dependent on their families, friends, and the society. So that prevents them from being economically active and socially included. So the IoT or the Internet of Things can offer people with these special needs with the assistance and support they need to achieve a good quality of life. And also, it allows them to participate in the social and economic life. And IoT and AI combinedly can help these special people a better read and understand their surroundings. So AI or the artificial intelligence can do some special things which we cannot even imagine at the moment. So in this topic, we are not going to cover the AI part. So if you read more on the artificial intelligence, uh, using some special sensors, they can detect the brain waves or the brain signals and operate these special robotic arms or limbs uh, as the uh, imagination of the people who need special attention. So these developments promote better understanding and can be of much use to those with visual or auditory and cognitive disabilities. So the second sector or the domain which IoT operates intensively is smart homes. So anyone can have a smart home provided that they have special IoT devices fixed within their homes to do special things in that particular home. Just imagine a house which is full of these smart devices. And let's say you have set the alarms to wake up in the morning. Let's say you want to wake up at 6 a.m. in the morning. So before the alarm rings, the kettle or the coffee maker and the toaster will switch on automatically, and the coffee maker will make coffee and toaster will toast the bread. So you don't need to wake up and switch them on. And as soon as the alarm goes on, lights are being switched on and the curtains or the shades will open. And when you go to the bathroom, it recognizes you. So it recognizes that you are the person who enters the bathroom, and it will set the water temperature as per your preference. And the mirror will work as some kind of an organizer. And while you are brushing your teeth with your smart toothbrush, the mirror will display your daily schedule and also the appointments. And at the meantime, your car will automatically detect the fuel levels and also the traffic on the way towards your office. And it will calculate the amount of time it will take you to travel from your home to office. And if the fuel levels are low, it will add that time to the traveling time as well. So if the fuel levels are low, you have to go to the petrol shed. That means you have to leave the house sometime prior to the uh, scheduled time or the normal time you leave your house. And your refrigerator will keep an inventory of the stuff you keep there. And for an example, let's say if you are running out of eggs, it will send you a SMS saying that when you are coming back home in the evening, you need to bring some eggs if you want to eat an egg in the morning. As soon as you go out from the house, it locks the doors and switch off all the lights to save the energy. And that, these are triggered based on the movements. And if there are no movements, the house recognizes that there's no one is inside the house. So it switches off these lights. And once you get into the car and when you tell the destination where you want to go, it will automatically start the engines. And if it is a car which runs with gasoline, the fumes emitted from the car will trigger the opening of garage doors. And now you might be thinking that I'm here, the presenter uh, is telling some sort of a fairy tale, but in next 10 or 15 years time, you will really experience. I mean, I don't think it will take 10 or 15 years of time, but probably in next few years, you will see that um, such a scenario will be a part of your normal routine. And if you go beyond the smart home concept, then you will find the smart cities. That means these IoT-based smart concepts are uh, taken in a bigger scenario. So smart city spans a wide variety of use cases, from traffic management to water distribution to waste management and urban security and environmental monitoring. And its popularity is fueled by the fact that many smart city solutions promise to uh, um get rid of the real pains of people living in the cities these days. So IoT solutions in the area of smart city will solve traffic congestion problems and reduce the noise and pollution, and also it will make the cities much safer. The thing about the smart city concept is that it's very specific to a city. So the solution which you will provide to a particular city would be a customized solution. So that cannot be applied as a whole into a different city. So the problems you faced here in Kandy are different from those in Colombo. And also the problems in a city like Mumbai are different from the problems which the people face in New York. So even global issues like clean drinking water or the deteriorating air quality and increased urban densities, which occur in different intensities in different cities. So that also can be addressed through the smart city concept. And if you consider Sri Lanka, so the majority of the people live and their lives are related to the agriculture sector. So there are so many things which we can do using the IoT technologies in agriculture. So if you have any sort of greenhouse to cultivate special crops, we can measure the humidity levels, the ventilation, temperature, the moisture of the soil, and so many parameters which related to the growth of these crops. So uh, let's say we have fixed some special sensors which can measure the moisture level of the soil. So if the moisture level drops below a certain threshold, the actuators will switch on, and that will switch on the sprinkler system. So if these devices are connected to the internet, and if these devices have the access to the real-time weather report, so instead of just switching on the actuators whenever they detect the low moisture at the soil, they can check whether the rain may come within next 1 or 2 hours. And based on that, I mean, if there's a higher probability of rain uh, in next few hours, then instead of switching on the sprinklers, they can wait till the rain comes, which will preserve the water. And also, if we combine IoT with the image processing technologies, we can identify the pest attacks, the fertilizer requirements that is based on the color of the leaves, and the growth rate and the growth pattern, and so many things. And let's say you want to cultivate some special crops which are not, which do not grow here in Sri Lanka. For an example, if you want to plant apples in Sri Lanka, sometimes you may have to create an artificial environment which will match the uh, weather or the climatic patterns in a different country. So in that case, it would be the ideal solution. And in fact, I have tried growing apples here in Sri Lanka uh, using the apple seeds. I have planted so 1 or 2 apple plants in my garden, but ultimately I got to know that due to the climatic changes, their leaves are getting dried up quite frequently. So IoT would have been a better choice if I grow them in a greenhouse. So the next thing which we can use in the agriculture is that drones. So drone is a different technology, but if you equip these drones with special IoT sensors and devices, we can use them in agriculture as well. So we can use it for crop monitoring and animal monitoring and building and equipment monitoring, and also for diagnosis of diseases and crop yield, soil erosion, wild game damage, and for so many things, you can use drones. And also, if you want to uh, drop seeds from the air, uh, for that purpose also, you can use drones. So here it is mentioned as spreading. And the next concept is connected cars. So this slide show some facts related to connected cars, which was predicted few years ago, but some of the figures have not been met due to some external reasons. Anyway, under the connected cars concept, these vehicles will mostly self-driven, and they can get the traffic measurements through the internet and with the support of nearby vehicles in finding the optimal route to their destination. Also, they can avoid collisions, minimize fatalities, and also can improve the driving disciplines on our roads. So that would be a great thing if we can use corrected cars on our roads, because the discipline level of the drivers you will find here in Sri Lanka on our roads is minimum. So this is how it would look like in a connected or a self-driven car. Just think of what you see here and what you don't see if you compare this picture with your own vehicle. So what are things you don't see here if you compare it with your vehicle? I mean, here you don't see a steering wheel, brake pedals, and also the gear stick. And we can't see a lever attached to the handbrakes, and so many things are not visible in this picture. Instead of that, you will see 2 or 3 monitors or the computers. Since it is fully automated and controlled by these computers, the security, what we've discussed in last session or the session prior to that, so the security will play a key role in the connected cars concept. So just think of a scenario where you sit inside one of the connected cars and a hacker gets the full control over your car. So what he'll do is that he'll drive the vehicle through the computer, and he will take you to a destination where he wants to take you to. And you will be helpless if you can't jump out of the vehicles and if the doors are get locked automatically. And if you can't open them, you cannot even jump out from the vehicle. And it may put your life in an utmost danger. So security should be in the highest possible level. And another area is the energy and power sector. So the smart grids will play a huge role in energy conservation. A smart grid is an electricity network or a grid which enables a two-way flow of electricity and data, whereby the smart metering is often seen as a first step. In smart grids, or smart grid as a concept became known over a decade ago and are essential in the digital transformation of the electricity sector. As the smart grid technology is implemented, it will lead to many benefits. So it is cost effective, hence will save your money and help conserve energy and improve the environment as well. The smart grid will eliminate the need for thermal power plants and enable greater use of renewable energy sources like hydro, wind, and solar. And in addition to that, the smart grid will generate new and rewarding careers in the field of green industries and also the energy sector. And uh, I'm going to stop talking about the IoT specific domains and applications from this point, but when you are doing your further researches and studies, do not limit it to the IoT concept, because there will be some other technologies which will not only improve the impact of IoT technology, but also which can change the humans' lives in next few years tremendously. So some of the examples are the robots, artificial intelligence or AI, the virtual reality, 3D printing, augmented reality, big data, blockchain, drones, and genetics. So just read more about these technologies when you have more time. So that will also helpful for you to do your future studies and even develop some brilliant and great applications. So I'll stop from here and I'll hand this over to Anuradha to talk more on the project aspects and how we can use IoT in your future projects. Thank you.
Thanks, Rajiv. Hello, everyone.
We can hear you, Anuradha.
And can see my slides?
Yeah, we can see it.
All right, great. So today is the last day of the series of webinars that we have been doing for the last 4 Saturdays. I think we had to skip one Saturday, but we continuously had these discussions. So as the final topic, as already communicated, we are going to look at IoT in undergraduate projects. But before getting into IoT specifically, I would just want to understand, or rather want to share my views on undergraduate projects. There have been a lot of changes since the time we were doing projects as undergraduates in the final year. So just by looking at the type of IoT applications themselves, just Rajiv just mentioned, you can understand the the size of the opportunity that you have in terms of selection. Like, one thing is you can do a project on IoT, and within IoT you have a larger spectrum of areas or different verticals that you can select a project on. But doing an undergraduate project, you can you can sort of approach the project in two different ways. One is just to complete your undergraduate requirements. Finally, a project, I think it's compulsory, just to fulfill requirement of your undergraduate studies and to make sure that you get the degree. That is one approach. The second approach is that you're going to become an engineer. You are going to be a graduate, Bachelor of Science in whatever the discipline, engineer, and you are interested about this, let's say, for example, IoT, and you want to really do some engineering work based on your passion, not just to complete a requirement stipulated by the faculty that you need to complete a project to get your degree. But the second approach, the second attitude, I would say, is based on your passion, that you really want to try something out, uh, in this case IoT, and try to sort of apply your engineering knowledge that you have gathered as an undergraduate, and try to use that project as a bridge to bridge your career, or rather start your career from undergraduate, graduate to, if you're entering the industry, using your project as a bridge to jump to the industry with more ease, right? Why I'm saying this is because, as you know, the things are changing, the circumstances are changing. We are living in a point of time where there's a pandemic around the globe, which we really don't know when it is going to end. And I think you are well aware that finding a job is also not easy in these type of situations. And if you can really select a project, start a project based on the passion that you have, and if it really actually, as Rajiv also mentioned, if it really resolves some of the problems that we have in the society, maybe in Sri Lanka or world at large, that could be your next job. Maybe you are not starting a job for somebody else. Maybe you're starting your own business based out of that project. So I really request, I humbly request you all to take at least to consider the second approach instead of the first approach, because that is where we can really do our engineering work, or rather apply our engineering knowledge and try to really become practicing engineers in the society. So before I get into the other slides, I just thought of sharing these tips, these 5 tips. I have already shared this with one of your colleagues whom happened to ask some questions from myself and Rajiv regarding uh, one of his initiatives. So some of the points that we have mentioned to him is also included here. Linking what I have just mentioned earlier, the second approach that I asked you to take is actually drives this first tip, which is having an entrepreneur mindset or entrepreneurial mindset. Not just to complete a project, but just to become an entrepreneur, being an undergraduate, right? There's no age or qualification for somebody to become an entrepreneur, right? There are school children who are entrepreneurs. So I want all of you to have, whether you do an IoT project or not, whether you do a project or not, I want all of you to have this entrepreneur mindset, that you have some sort of confidence on you that you can really try out something with the knowledge that you have gathered. And specifically on IoT, I think you saw the type of applications available and the type of application, because IoT is a growing field, and it is always recommended, and it's a good way to start with customizing already available some open source software and hardware, rather than trying to reinvent the wheel, which of course you can. But take, for example, Red Hat Linux, right? What Red Hat Linux, or for that matter, SUSE Linux or Ubuntu or Debian or whatever the Linux flavor that you use, it actually uses open source Linux kernel and adds whatever the marketing or whatever the other features as a wrapper, and sells Red Hat as a Linux. So I'm not saying that you should take the same approach, but that may be also not the best example. But what I want you to understand and also to consider is that if there is something available, especially open source, right? I'm not saying that you should use somebody else's work, because then there are patents and rights and all the other things, royalties involved. But the easiest way to start is to use open source, because today open source is not just software. We have hardware also on open source, especially when it comes to the open compute project. Uh, Open compute project, there are a lot of things on hardware which are open source. So try to take one of those open source capabilities and try to customize or modify the way you want. And the third thing is very important. We being Sri Lankans, and rather than complaining the governments, the politicians, and the rulers that we are still a developing country and they are not doing anything, I think it's good time for us to ask the question ourselves what we are doing. So as especially undergraduates and engineers, to find solutions. So in that context, I want you to think, if you are trying to do an IoT project or any project, try to think about local conditions. Uh, Try to, for example, think about the local language support if you are developing an app for IoT. And the probe, sensors, actuators, all these gadgets in the hardware level, try to find, or rather develop, customize to suit local conditions, like the tropical condition. Like these days the temperature is something like very close to 40 degrees Celsius, and the humidity levels and the different circumstances, like we have wildlife uh, situations, we have wild elephant situations, we have like crazy drivers who are reckless in the roadways. So try to use this local mindset and local conditions included in your project. And also try to use an approach where your final product or the project or the solution is, it's simple in design and also simple to use, right? You don't want to come out with a product or a solution which is so much complicated, so that the end user is is required to have a special skill to use the product, right? You cannot actually, unless it is a very specific product which is to be used by doctors or like say some other special group, but you can think the larger society and come out with a product or a solution which can be easily used by end users. And you can use the other approaches like open, modularity, disaggregated, which we I think discussed earlier. Try to, rather than developing one big monolithic system, try to have subsystems, modular, different modules, and have disaggregated disaggregation. You can have disaggregation in the hardware level. You can have disaggregation in the software level. You can consider the full stack, the full IoT stack, and try to do layered approach, different modules, so that if you are doing it as a team, you can actually share the workloads because you are using the modularity principles. And another advantage in that approach is actually you can combine with multiple project groups. For example, now if there are like 3 or 5 groups doing IoT related projects, one may be doing a project related to hardware, one may be doing something related to an application development, another time may be doing the interfacing, communication channels, security, maybe encryption, maybe management, maybe the interface. So you can combine all these projects, there are multiple projects, and try to like build one program where all these projects are included, and finally you actually come out with very larger capability deliverable, right? So I hope you are getting uh, what I just mentioned. And the fifth thing is also related to what I initially mentioned. Try to find a problem area where there is no solution at this point of time, or maybe the available solution is not efficient, not effective, maybe not optimum in terms of cost or in terms of user friendliness. And you can, if there are so many identifiable defects in the current solution or the product, you can improve them. So that is one approach. The second one is that if there is no solution at all, then you actually try to come out with the solution, right? So these are some high level tips. You can apply these tips not just on IoT projects, but you can apply them on any projects. But in this case, we are looking at IoT. Now, getting into IoT, the rest of the slides are actually not really developed by me, but I have gathered some slides which my intention is actually to sort of awake your mind to think about the possibilities in terms of selecting an IoT related project. But I'm not going to sort of dictate you this is how to do a project, which is actually not necessary for undergraduates at your level. And anybody who's having that level of education and understanding. What I'm really trying to do is try to sort of make you aware that the size of the opportunity and the areas that you can direct your mind to sort of grab something related to IoT project, right? So as a result, I would really expect at least some of you to rather pick one of these, could be crazy ideas, but select one of these ideas and try to build on top of that to come out with really useful thing to the society at large. The second approach, I really don't want you to sort of make it, I mean, just for the sake of doing a project to complete your undergraduate and just become a Bachelor of Science, whatever. So I really don't want to see that approach, and also I really don't want to. I really don't recommend that type of an approach, but rather I would like the second approach. So some tips. I think the low cost. like especially in the countries like ours. Wider coverage, high quality. And I think Rajiv mentioned once about the battery life, durable batteries, low latencies, right? And global availability, security, reliability. So these are some of the things, irrespective of the IoT project that you want to select, but you have to make sure that at least you try to sort of match these requirements inside your project. So that actually makes your project uh, more biased to the second version of the approach that I said, because you really don't care if you are doing the project for the sake of completing your degree, then you really don't care on much of these things, like for example, uh, battery durability, uh, low cost, right? So those things are usually not cared of. But if you take the second approach, you need to include these things in your project. But I would rather call that as a product or a solution than a project, right? Project is to complete your undergraduate requirements, but what you are really doing is not a project. You are actually developing something. You are developing a solution or a product to address a real human or a society requirement, right? So that approach is very important. And when you're trying to do these things, there are certain things, restraints, opportunities, challenges, and things like that. And I think this slide and the rest of the slides I'm going to share with you related to agriculture, because we are an agriculture-centric country, even though we actually not give the due recognition over the years. Like those days, you know that we are very rich in terms of agriculture. We still are, but the approach and the recognition given by the people, government, and the state is not at that good at this point of time. So I'm taking agriculture as an example just to give you some tips and ideas that how you can sort of think of doing an IoT project. So there are a lot of drivers. I think Rajiv also mentioned in the area of agriculture, and connectivity is one of the issues in Sri Lanka, because agriculture is done mainly like paddy farms, paddy fields, and then animals like cows and all the other livestock development. These things do not happen in towns, right? You know that these things happen in maybe very rural areas, like if you go to Ambevela and if you go to some other areas, you know, we really don't have network as such in these areas, because we only see trees and vegetation and the farm animals, right? So people do not go and develop connectivity solutions to these areas. So you have a challenge, right? And you are supposed to find a solution. It could be a satellite solution, it could be a low energy, some solution that, for example, you erect a tower or a small radiation RF technology. We have a lot of private networks being developed just to connect communities. So that sort of approach. And the type of opportunities, I think I need not mention, not only in agriculture, we have a lot of opportunities in other areas as well. And for example, you also need to think like, if you develop something, if you develop a solution, how easy for you to actually take it to the market. And for example, if the end users are the farmers, the farming community in Sri Lanka, you know that they really don't speak English, they really don't understand English. You have to really go with the local language and the interfaces. The, of course, I think they most of them use a smartphone these days, but there are certain changes that you have to make in your approach to make it to local conditions and local community. Some use cases like I think Rajiv mentioned most of these things. Like uh, one approach is that whether it is agriculture or not, you can focus yourself, for example, developing, take the stack, take the IoT stack. You can start at very bottom, which is about your sensors and actuators, the physical, mechanical, maybe things at a very physical level. You have to develop hardware things, hardware components, and maybe you can go a little bit about the stack and see the type of communication challenges and try to address that. And then you can go to another different area where you really don't see any hardware, but you really work with the software, meaning the data, right? You can do data analytics, you can do data artificial intelligence, and the other things that Raji also mentioned. You can combine all that, the collected data, and you really become a data scientist, or something very much lenient to the software side of IoT, develop something. And going above that, you can sort of do some sort of APIs interfacing, and try to come out with software application just to control these IoT devices or IoT things. Or maybe you can develop a project or a solution including everything, meaning full stack, but that I think it's doable, but uh, that involves a lot of things. It involves hardware, it involves interfacing, communication, it involves software, it involves APIs, applications, application developments, web interfacing, all that, right? So your spectrum is very large. Instead, you can also take a slice and do your project and uh, at that approach also. And if you are selecting that approach, take a piece and develop. You have to also make sure that how I am going to integrate this with the upper layers and also the bottom layers, right? That basically comes with the interfaces and the APIs. You cannot just develop something which has like closed APIs or very proprietary APIs. So you have to make sure that if you are developing a part or a piece, a solution, you have these open APIs so that you can actually go and plug in to an existing IoT stack where somebody else may have developed the other parts, right? I hope you are getting what I'm trying to convey here. Raju mentioned smart greenhouse, so I'm just giving you some ideas, right? So I'm not I really don't want you to pick one of these ideas as your undergraduate projects. Most of these things are already available in the market, or most of these things are already tried out by other undergraduates, maybe in Sri Lanka, maybe outside Sri Lanka. So I'm trying to give you some ideas so that you can maybe pick one of these ideas and try to give your own approach and try to come out with a different solution. And if you find anything inefficient, anything ineffective here, you can sort of correct that as well. Type of things, and you can measure, for example, precipitation, radiation, plant health. There are a lot of things that you can measure using one of these sensors. And best thing that you can do is to think local, right? Most of these devices or the sensors and actuators, they are actually the generalized version available in the market, maybe not very much suited to one of these local conditions in Sri Lanka, right? So you can probably pick that up. What is that thing that is not being addressed by most of the common IoT sensors or most of the common IoT actuators and IoT platforms or applications, and take that and try to develop that, and maybe you can integrate that to this. And the good thing about that is that uh, so many things which are local to us could be local to the other tropical countries around the equator, like us, maybe some countries like India, Malaysia, which are having the same environmental conditions. So if you probably try to find a solution to one of these issues that we already have that could be easily duplicated in other parts of the world as well. So these are some of the things that are available, the sensors, and you can also see some of the prices, right? So how cheap or how expensive they are, right? So for example, uh, an adapter like this about 15 US dollars, and something like this 4 sensor kit uh, close to like 1,349 US dollars. So these things are pretty expensive, and if you can, for example, try to analyze and develop a kit, for example, using a low cost display unit or something like that, that would be great, right? So what goes inside in one of these sensors? There's a SIM. That is their approach, but you can use I don't know, you can use any other technology. If Wi-Fi is available, you can use that. So you can try think yourself to sort of in this case how to bring this cost down, for example, right? Low cost sensor. So that is your approach. And this is one thing to monitor farm animals like cattle and cows, for example. There are a lot of ear tags being used. Uh, these things, for example, can be tracked using GPS, and you can think of local issues related to this type of an approach, right? We are a country where people sort of rob not only physical things, but they rob cows as well, right? So for example, that is an issue, like farmers lose animals because people go and uh, like there are a lot of things that not only human trafficking, we have farm animal trafficking also. Rather than tracking the these cows and the cattle, we maybe find a solution for this illegal uh, uh, animal trafficking, right? So that is how you actually relate this type of an approach to local drones. Of course, I think being used in many fields, not only in agriculture, but again, think what sort of issues we have in terms of using drones in Sri Lanka. Like for example, how easy or how difficult it is, or is it for a normal average farmer with a smartphone to control this type of a drone? Or can it be controlled by somebody else? Or if that is the case, how you actually address the security, reliability, and that sort of things? And what needs to be improved uh, to actually make sure that using drones for, let's say, for seeding or weeding or whatever, reading, or maybe for fertilizers, or maybe collecting or picking crops, for example, how to make sure that actually suits the local condition, and what need to be improved. So that is what I earlier mentioned, that you really don't have to develop the IoT stack as your project. Now, for example, these things are available, but what needs to be fine-tuned for this to be directly applied in, for example, in one of the paddy fields in Polonnaruwa, right? So, so you really need an approach, not just engineering approach, not just technology approach. You need to have this people approach as well. If you really want to do this, and let's say you're trying to, for example, introduce this type of a thing to a farmer in Polonnaruwa, right? you really have to go to Polonnaru and speak with these farmers, and you have to probably go to a paddy field. Maybe you have to sort of step in to the field. You need to like feel how it is, the watery conditions, the muddy conditions, and how these people actually do these things today. So you really need to go to that level and understand for you to develop or improve that solution, right? So this actually gives you uh, it gives you a good chance for you to sort of go and meet local people. I'm not sure how it is possible these days, but still people actually move compared to the first year of COVID. Now people actually move. People do farming. I think you, with all these health guidelines being addressed, you can also go and meet them. So this gives you the real approach to your project, right? Rather than just doing the project inside the faculty or maybe inside home, this actually opens it up to, and it actually makes you much closer to that entrepreneur mindset, right? So that makes you really passionate about what you are trying to do, rather than thinking that I have this deadline of completing a project, but rather you are trying to find a solution to a local community. If you look at the market, there are a lot of solutions available. I'm actually taking agriculture because still believe agriculture, if we can improve agriculture in Sri Lanka, we can find solutions to most of these problems that we have today. Uh, this is one thing available in the market by Bosch. I think Bosch has the best sensors and actuators in the market. They are really good at that. So we really don't want to go and sort of build that type of a sensor. That you probably would use one of their sensors, and maybe um, use a gateway and use some sort of analytics, right? And maybe your analytics are more closer to the local conditions, right? You analyze, let's say now these days, those days I think we had this one special insect attacking, I can't remember the name, uh, attacking the crops in Sri Lanka, and people were trying to, I think a team came from Africa also to find uh, a solution. So I haven't seen people actually try to use the collected data and use artificial intelligence, machine learning, and all these data analytic stuff, data science stuff, to come out with a scientific answer for that. So I haven't seen people doing enough analysis based on the collected data. One reason could be that they have not collected data, right? Other thing is that even though collected, they have not tried to use the data analytics approach here, right? So that is one example. And if you go above the stack, right? If you really think that you need to develop a platform, and you want things like high processing, and you want some sort of analysis, analytics, these things are already available. For example, with people like AWS, they have different services in their cloud, right? So you can use these things because they are available. Maybe some of these things are available for trying, but you really don't have to develop some of the things if the things are already available. And again, in euros, this one particular sensor box cost you something like 325 euros, and multi-network gateway cost you something like 739 euros. So can we really use something in our farming community? The costs are very high, right? So you really need to sort of think how to bring these costs down in terms of making it suitable to local conditions. Smart Cultiva is another company who are using a lot of sensing technologies. These things are not that expensive, but could be expensive if you really take a farming community in Sri Lanka, ranging from so many like 100 US dollars to 300 US dollars, pretty expensive in terms of our local conditions. And some of the IoT platforms already available, right? You can go and check. There are a lot of IoT platforms available with the AWS, Google's, and also Azure, and there are specific IoT platforms as well. Uh, Go check, for example, this one, 500 devices, 750 US dollars per month. Can we really develop something suitable to local market, right? With low cost, probably one of these service providers can help, like SLT. We have data center capacity. Maybe if you come out with a good proposal that we are trying to host this type of a platform locally, maybe we can discuss for better pricing as well. This is another example. I'm sorry, I have taken all these agriculture examples because you can very easily map that to other areas as well. But we don't have really time to discuss all the verticals in IoT project related things. But I'm taking agriculture for a very valid reason, because you and me actually can help Sri Lanka to come out of all these problems if you really apply IoT type of technologies in agriculture in the right way, so that we can find solutions and be much effective and efficient in terms of our productions in agriculture. So, these sensors, something like 2,500 US dollars, 1,500 US dollars, just to control water irrigation, right? So maybe you might think that if these approaches, these capabilities, these devices cost this much, maybe we have enough people, but still we can use our own way of controlling irrigation that of course we do today. But uh, again, you have to use a techno commercial evaluation to see whether it is efficient or productive in the long run. If you take the total cost of ownership for a period of 5 years or 10 years, uh, taking that particular application as a project, you can see your investments on this type of mass irrigation is this. But if you do it otherwise, what are the issues and what are the inefficiencies that you have? So that also could be an IoT project, right? But very valid IoT project. I think you have seen this, how to control fertilizers, different chemicals, I don't know, indicated by different colors, and try to use a mobile app to control based on the indications. And this is an alert system when the cows are about to give birth to the baby cows or the cattle, and this senses the accurate timing for that, and inform the farmer that this particular cow is about to give birth to a cattle. So these are real examples where we are trying to address a real life problem, right? The reason why I'm selecting this type of an example is not for you to develop this type of thing because this is already available. Maybe you can develop something of low cost which suits local conditions, but think of the people who have actually come out with this MOOC call type of solution, uh, their approach to the problem, right? So for you to sort of take this type of an approach and find a solution, you really have to go and meet these farmers who are doing cow breeding and all these cow related stuff, and really need to understand the life of a cow and what sort of things happen in a daily routine. So only with that type of education and knowledge that you can actually sort of harness that with technology and come out with a technical solution which actually address the real life problem, right? So that also gives you a real opportunity for you to uh, sort of awaken your other parts of the mind, other parts of the brain, because we being engineer, you being undergraduates, we are very much molded ourselves to think in engineering terms, right? And you know very well that the person who actually painted Mona Lisa, Leonardo da Vinci, he has multi-talent, right? Why he was really good at science, why he was really good at engineering type of application, because he was actually equally good at arts, music, and other stuff. So similarly, if you can sort of blend your engineering knowledge with the other knowledges in the society, we say that informal learning, like how farming works, how cow breeding works, and all these things, then of course it actually has a mutual sort of relation to your engineering knowledge, right? Just by having your engineering knowledge, it's very difficult to find a solution to a real life problem, right? But if you really understand the real life situations, and then you get your situation where you really understand, okay, this is the problem and this is how I am trying to relate that problem with an engineering solution, right? So that is one thing. So these are similar examples. I'm not going to discuss these things. And pest management, right? That particular thing, I think we had this issue that was called Sena Dalambua or something, right? One particular uh, insect or a pet pest came to Sri Lanka. So how to tackle that type of a problem? So take real life problem and try to develop a solution, in this case using IoT approach. Mobile robots, of course, we have in everyday life, but again, think like, for example, what you see in the picture, just to move these uh, pots, do you really need a robot in Sri Lanka? I really don't think, because we have enough labor, we have enough people who are actually not having jobs. Very easily we can ask a person to do this one. But there are other places where we can use robots uh, for other purposes as well. And not only in agriculture, there could be sensors for aquaculture, right? We have fish cultivation, we have a lot of vegetable now these days just cultivated just on water. So think of sensors maybe used to lay, for example, monitor and increase the harvest of, let's say, prawns cultivation in lagoons in Sri Lanka, right? So if you take lagoons in Sri Lanka, for you to really understand what really happens in terms of prawn cultivation, you have to go there and see what really happens. Then only you understand that these are the issues, and maybe I can help with an IoT solution. So finally, this is Orange in France develop a kit for IoT. Unfortunately, we don't have these kits available yet in Sri Lanka, maybe in the future. For example, what they have done is use a 4G SIM, a battery, SD card, some IoT board, and 4G modem and antennas, and developed 4G kit for IoT, right? So this is also another approach. You can develop a kit maybe uh, for for other undergraduates to start project. Uh, you can develop a kit for uh, prepare and undergraduate experiment, lab work, or something like that. Okay. And in terms of collection, you can think of real-time data collection and non-real-time data collection. Some of the success stories, this you can go and read. This website, eKakashi in Japan, where they are doing 24-hour, 365-day cultivation. Not just Yalamaha and all these things, but full-time cultivation using IoT. I'm not going to explain. They're using AI brain, just collect information. The more information, the better, and try to use this AI engine and come out with predictions, recommendations in terms of smart, sustainable agriculture, right? I think you can see the logo here. It's being sponsored by JICA, and so this is something in real local farming conditions, I guess, in Japan. And also we have things in Pakistan, M-Agri ecosystem. They have been using this for quite some time. And coming to Sri Lankan situation, we have something called e-agriculture strategy, right? You can go and read that. I think it's available in Sri Lanka e-agriculture strategy. If you search for in the internet, you can find. So I think we have one strategy, but we need to go and see at what level it has actually delivered results in terms of using IoT really in Sri Lanka. So these are some of the extracts from ITU for ICT in agriculture. And CIC, one of the companies in Sri Lanka, they have actually done this a couple of years back, targeted weed killing and targeted weedicide spraying, for example, using the cameras and clearly identifying only the areas to be sprayed, right? Otherwise, what you see, if you go and speak with a typical farmer, they spray the entire field just to maybe because they are not aware where these weeds are really growing, right? But if you can use this type of intelligence, you can really sort of see and save money, time, and maybe increase the health uh, like that. So with that, I also conclude my session, and the whole objective of sharing those things is actually to uh, like awaken your mind and make you aware of rather than confining yourself just to think finally IoT project, open your mind up and see the opportunities available and try to become a real human being, not just an engineer, but with a more human approach, and go to the community, go to the field, go outside of your comfort zone, and try to be with people, the communities, and sense their issues, and then apply your engineering knowledge to find a solution and make it a sort of a passion and something that you really like and love, rather than just confining yourself of this projecting, right? So I hope that helps. And if you really want to contact myself or Rajiv, these are my contacts: email, LinkedIn, or Twitter, or you can follow us on our YouTube channel. Thank you very much, and it's been a real pleasurable 5 weeks, 5 Saturdays, both for myself and Rajiv, to share our little knowledge on IoT. And we really hope that you guys use these small tips in your undergraduate projects and elsewhere. And let's keep this relationship and the contacts going forward. Thank you very much. Do we have any questions?
There's one question, Anurad.
Something Rajiv you can answer, or
It's related to that, what you call that breeding thing you mentioned.
okay. Will radio affect the internet generated? Will radio affect the effect of the internet generated by IoT maintain a healthy environment around the livestock and crops? We should be aware of that as well. Yes, you are correct. So we normally see RF, right? Not just anything else, but radio frequencies are very much depending on the frequency and very much depending on the power that frequency wave carries. Both animals, including us, and livestock, and also agriculture, we both being animals and trees being very much with including we have our bodies like larger percentage of water included. So water absorbs these RF energy. So we have to think about that because whenever RF signal travels through on top of water, on top of vegetation, then of course there are certain issues because of the absorption. So yes, one thing is that you can do a project to try to avoid that and find a solution. Uh, these things will help, for example, like private networks, rather than depending on an external GSM signal or something like that, which is far away, which has to cross different areas, but try to build a private network, maybe Wi-Fi, because but then use that RF just as a backhaul. Because what is more important in IoT is the collection of data. So if you have the right sensors, right actuators, if you can collect the right data at the right time, it may not be necessary sometimes to update your databases in real time, but as long as you have collected, because these things are not like a remote surgery that you have to take the decision then and there, right? But these are monitoring data. For example, you can ask your cloud engine to analyze the data once a week, right? So it is good enough if you can actually transport the collected data to the cloud at least in that week's time. So the most important thing is that you collect the data and your data is safe. So I hope that addresses, but you can think other areas as well.
Anuradha, I'll add something to that. I mean,
Yes.
in previous sessions, we discussed the technologies or the access methods which can be used in IoT. So most of the access methods which we discussed earlier related to the low power area.
Yes.
But if you consider the smartphones which we keep in our pockets on daily basis, they use the high power RF signals to communicate with the 4G, 3G, or in next few years we'll talk about the 5G base stations. So the radiated power in the smartphones are much higher than the power levels of the IoT devices. So if we think that the IoT devices may cause something bad to our health, before that, then we have to get rid of our smartphones, isn't it?
Yes. And Janit is asking, what are the main difficulties when we are going to start a smart home company in Sri Lanka? I'm asking about network, storage, cloud, and security. Of course, in terms of network and storage, we can help as Sri Lanka Telecom. We can provide the connectivity. And also we have our data centers. If you want to host anything locally, we can do that. Security also we address to a certain extent, but places where you actually need to harden security, you can come out with your own solutions. I think we can help you in that regard as well. And yes, you are welcome. It's great to see that small knowledge sharing helps people in terms of finding solutions to these things. Great.
And I'll add something to Janit's question. So as Anuradha clearly mentioned, the crucial factor will be the security. So when you are developing your own smart home solution, you have to make sure that you have applied enough security which cannot be breached by the external parties or the hackers. So if there are vulnerabilities, so any third party or a hacker can exploit it. And if there's a security breach, then that will be the end of that particular product. So because the trust the people keep on that product will be lost. So thereafter, no one will go and buy that particular product.
Yes, sir. Thank you very much, sir.
You're welcome, Jani. If you have any questions, please write to us, Jani.
Okay, sir. I have already had a conversation with you via email.
Yeah, I remember. Yeah.
Yeah. Okay. Thank you very much, sir. Thank you for your contribution.
Yeah, you're welcome.
Anybody else or anything else? So this doesn't mean that we are actually sort of winding things up, right? So I think this is just a start of a great relationship with all the participants, myself and Rajiv. So let's keep the communication going. If you have any questions, any doubts, any help, you can always contact us. So if you don't have any more questions, I think Isuri, we can.
Yes, looks like that's all the questions from the audience. I would like to mention that we have put up the link to the feedback form. Make sure to fill it to receive the certificate of participation, and make sure to provide the name you want in your certificate in block letters, preferably your full name. And with that, we have come to the end of this 5-session long webinar series. On behalf of IET on campus, I would like to take a few minutes to express my gratitude towards the guest speakers of this event. Mr. Rajiv Weragama, sir, thank you very much for spending your valuable time for this event despite your busy schedule. And we are grateful for all the educational knowledge you have shared with us. Since we can't meet face-to-face with the current situation in the country, please accept this virtual token of appreciation presented on behalf of IET on campus, University of Peradeniya.
Thank you very much, Isuri.
And Mr. Anuradha Udunuwara, my heartfelt gratitude goes towards you as well, sir, for sharing your insights on IoT and allocating your time to educate these young minds. Please accept this token of appreciation presented by IET on campus, University of Peradeniya.
Thank you very much.
Before winding up this session, I would like to invite the Secretary of IET on campus, University of Peradeniya, Ms. Hansika Gajanayaka, to deliver the vote of thanks.
Good evening, everyone. First, on behalf of the IET on campus, University of Peradeniya, I would like to thank Engineer Anuradha Udunuwara and Engineer Rajiv Weragama for their valuable contribution. They are always looking forward to giving a helping hand with their best for any time we ask. I would like to acknowledge and experience with us. Throughout the series, for more than 6 weeks period, their cooperation with this event was remarkable. So I'm very happy to thank and appreciate both of our experts, Engineer Rajiv and Engineer Anuradha, at this privileged moment. Also, we expect your valuable contribution to our future events as well. I would like to thank all the participants who have joined us throughout this session, and we hope that we made a golden opportunity to encourage you to make the first movement into the IoT world fearlessly. Next, I would like to express my sincere gratitude to the IEEE Sri Lanka Central Region Subsection and IET Young Professionals Committee for giving their cooperation advice throughout this whole event. Also, our Senior Treasurer, Dr. Sudhira Navaratna, for always supporting and being with us. Finally, I would like to take this opportunity to thank and appreciate the IET on-campus University of Peradeniya Committee and volunteers for the tireless dedication throughout this event. And also, I would like to especially thank Hashini Utpala, event chair of this Step to IoT event, who worked so hard for the success of this event, and Isuri Devindi for the comparing the session with great passion. As we all know, this pandemic situation in the world makes our lives open to a new technological era. Let's take the advantage of this opportunity. So, I think as an intentional society, we did our best to achieve that goal. Hope to see you all at our future events. Thank you and have a good night.
Thank you, Ms. Gatchanayakar. So this marks the end of this webinar series. We sincerely hope that all of the participants will continue to learn about the field of IoT with the aid of the stepping stones we have provided throughout this webinar series. Thank you for joining with us and hope to see you all in future sessions as well. Have a good night.
Good night to you all.
Thank you. Good night.